The two keywords from the lesson are optimization and linear programming. Optimization means the process of finding a minimum value or a maximum value for a specific quantity. For example, we want to either maximize profit or minimize costs. When the quantity to be optimized is represented by a linear function, the process is called linear programming. The two-dimensional linear programming problem consists of the objective function, which is the linear function to be optimized and is of the form f of xy equals ax plus by plus c. And it also consists of a set of constraints, which is a system of linear inequalities. So when we graph the system of linear inequalities, we get something similar to this. The solution set of the system of inequalities is the set of possible solutions or the feasible solutions. Now, if you look carefully, this set of feasible solutions contains infinitely many points, making it impossible to evaluate f of xy for all of them. To overcome this, we use the vertex theorem for optimization, which basically uses the corner points of our feasible region. So what exactly does the vertex theorem for optimization state? The theorem states that if a linear programming problem can be optimized, an optimal value will occur at one of the vertices of the region representing the set of feasible solutions. For example, the maximum or minimum value of f of xy equals ax plus by plus c over the set of feasible solutions graphed occurs at A, B, C, D, E, or F. Now, when we want to solve a linear programming problem, there are certain steps that we should follow. So the first step is graph the region corresponding to the solution of the system of constraints, which basically means to graph the system of linear inequalities. Then you find the coordinates of the vertices of the region formed. So wherever those lines meet, you find those points of intersection. And then you evaluate the objective function at each vertex to determine which x and y values, if any, maximize or minimize the functions. So in all, we have 3 steps to follow for any linear programming problem. Let's look at the first example. Here we want to find the maximum and minimum values of the objective function f of xy equals x plus 3y, and for what values of x and y they occur subject to the following constraints. So we are given the 4 constraints here. Now the first step is to graph the region corresponding to the solution of the system of constraints. So we graph all the 4 inequalities and find the feasible solutions. Next, we want to find the coordinates of the vertices of the region formed. So as you can see here, there are 4 vertices. The first one being at 0, 0. And for the other 3, we solve the different systems of equations. So when we solve these 3 systems of equations, we get the other 3 vertices. Next, we evaluate the objective function at each of the 4 vertices. So we substitute the values of all the 4 vertices to get the value of the objective function. Now, as you can see, this is the minimum value, 0, and 24 is the maximum value. So the maximum value of 24 is when x is 0 and y is 8. And the minimum value of the function is 0 when x is 0 and y is 0. Now it's your turn to practice a few questions. You can pause the video and resume when you're ready. Now let's see the answers. For the first one, the maximum occurs at 0.8 and the maximum value is 40, and the minimum occurs at 0.0 and the minimum value is also 0. And here the maximum occurs at -2, -6 and the maximum value is 26, while the minimum occurs at -6, 6 and the minimum value is -66. Let us now look at a real-world example where we use the concept of optimization with linear programming. There is a company which makes audio players and phones. If at least 2000 items must be made per shift, how many of each type should be made per shift to minimize costs if the following has to be kept in mind? So the production per shift of audio players can be minimum 600 and maximum 1500, and the cost per unit means cost per audio player is 55 dirhams. And similarly for phones, you can produce 800 phones per shift minimum and 1700 maximum, and the cost per unit is dirhams 95. So the first thing that we have to do here is to write an objective function and a list of constraints that model the given situation. So for writing an objective function, we first need to define our variables. So we can write let A be equal to the number of audio players produced and P be the number of phones produced. So based on this, what will be our objective function? We are looking to minimize costs. So to write the objective function, we would look at the total cost and try to minimize it. So our objective function is given by a function of AP, which is 55A plus 95P. So this is our objective function. Now we need to define the constraints. These are our three constraints. For the number of audio players, we have a minimum and a maximum. So we have 600 less than equal to A less than equal to 1500. That's the first constraint. Similarly, for phones, they can be between 800 and 1700. So we have 800 less than equal to P less than equal to 1700. And also it's mentioned that they have to make at least 2000 items. At least means 2000 or more. So the total of A and P should be bigger than or equal to 2000. Along with this, we have two more constraints. Because A and P cannot be negative, they are the number of audio players and number of phones produced, they cannot be negative. So there are additional constraints that A should be positive and P should also be positive. So this is our list of constraints for this objective function. Now next we will graph the system of inequalities, then find the coordinates of the vertices of the feasible region using systems of equations knowledge. So once you graph your system of inequalities and find the feasible region, you find the vertices of the feasible region. So here we have 5, and these are the different coordinates of the feasible region. You find them by finding the points of intersection of each line and solving the system of equations. Next, you find the value of the objective function at each of the vertices. So now if you look here carefully, this is the maximum value and this is the minimum value. And what are we looking for? We are looking to minimize costs. So this is what we are concerned in. So in order to minimize the cost, the company should produce 1200 audio players and 800 phones. Now it's your turn. Read the question carefully and then write an objective function and a list of constraints that model the given situation. Also, you need to sketch a graph of the region determined by the constraints to find out how many units of each type of wood product the mill should produce to maximize profit. You can pause the video and resume when you're ready. Let us now check our answers. So we first define the variables. Let x be the lumber and y be the plywood. So the objective function would be f of xy equals 30x plus 45y. And the constraints are x bigger than equal to 150, y bigger than equal to 225, and also x plus y less than equal to 600. And then you graph the system of inequalities, find the three vertices, evaluate the objective function at the vertices to get the answer as the mill should produce 150 units of lumber and 450 units of plywood to earn a maximum profit of dirhams 24,750. I hope you got the correct answer.